Data in databases are organized in rows and columns into tables for easier navigation and retrieval. Database handlers manage many websites online, allowing access for users with specific software programs. Examples of databases managed with database management systems, or DBMS, include MySQL, SQL Server, MongoDB, Oracle Database, and PostgreSQL. Structured Query Language, or SQL, is commonly used for data manipulation within these systems. Database architecture refers to creating, implementing, and maintaining DBMSs. Oracle was the most widely used DBMS globally as of June 2024, according to LinkedIn. A DBMS allows dividing a system into different components that can be modified independently. Understanding its components is crucial for efficient data management. There are three main types of DBMS architecture: one-tier architecture, two-tier architecture, and three-tier architecture. Additionally, there is the N-tier architecture. One-tier architecture, where the client, server, and database reside on one machine, is the basic DBMS architecture. This architecture is typically used for practicing SQL queries on personal systems or as learning platforms. However, it is rarely put into production use due to its limitations in scalability and security. Two-tier architecture involves having two layers in its architecture that communicate to store information securely. Typically, data is located on servers rather than being exposed directly to users. This architecture provides more secure communication while still permitting direct and quick exchanges of information between layers. An example is an MS Access-built contact management system that effectively organizes contacts. Three-tier architecture is one of the more prevalent client-server DBMS architectures. It features modularity that facilitates separate development and maintenance modules for logic, functional processes, data access storage, user interface, and data storage use. The layers of a three-tier architecture are the presentation layer, your PC, tablet, mobile, the application layer, server, and the database server. This architecture expands upon the two-tier client-server architecture. N-tier architecture involves dividing the application into three different tiers: the logical tier, the presentation tier, and the data tier. Unlike the Model View Controller, MVC framework, which separates elements physically, N-tier architecture separates them logically or conceptually. All communication must go through one centralized logic layer. This architecture ensures that nodes may be distributed across different racks within one data center, or even across several data centers. High availability refers to databases with higher than usual uptime agreements. This is achieved through eliminating single points of failure and switching seamlessly to redundant servers. High availability databases monitor faults continuously to initiate failover promptly, ensuring uninterrupted service even with network latency or hardware malfunction. A high availability system, HA, is designed to run continuously without interruption. It doesn't mean the system will never make errors, but it is designed with enough redundancy to handle errors without causing wider failures. High availability databases switch to redundant nodes automatically when problems arise, ensuring continuous operation. To design a highly available database, eliminate single points of failure in internal database components and run a duplicate database copy. Use multiple redundant hard disks designed to withstand single drive failure in RAID 5 and 10 systems. Data partitioning allows for storage and grouping at various locations, improving performance, security, and scalability. High availability database solutions were once intended for mission-critical applications, but now users expect any web platform to be accessible at all times. An effective high availability architecture eliminates all single points of failure by including at least one cluster with high availability nodes. Understanding your application is the first step toward designing such an infrastructure, ensuring a responsive and reliable system.